Okay, I'm going to work with this absolute value function now. One thing that's not really clear is why it's written in this form. Um, Essentially, this derives itself from the fact that when you take the derivative of this function, which could be written this way, so I'm sorry, negative x and an x, sorry. Okay, so it's equal to this, which then when you take the derivatives, notice it's the same function, but there's a negative sign in front of this part. So the only difference is the negative sign. So we will have exactly the same derivatives, but opposite. Okay. So another way to write this function, something that has a negative and a positive. So a shorter way to write that, to indicate that, and also notice that there is a, when you take the derivative here, d dx of this function, you're going to get a negative 1 here and a positive 1 here. So you see there's a discontinuity in this function right at 0. To preserve that, typically the derivative here is written this way. And this preserves the fact that this quantity, because remember, this thing here will be a negative x for x less than 0, the denominator, which makes negative 1 for x less than 0 or equal to 0. And undefined right at 0, so it preserves that. And then when x is, actually I need to, sorry about that, I need to, right here, one of these can't be both, so we'll do it like that, okay? You can't have both. So, okay, so this preserves the fact that this is different in sign and that it's undefined right at x equals 0. So this is our standard form. Now, if you replace that x with a function, u of x, then you just enlist the chain rule. So you'll have u of x over absolute value of u of x times u prime of x. So that's where this is coming from. It's really just a plus or minus 1, but it indicates that it is undefined wherever the u of x is equal to the, well, wherever that break is, okay, wherever that occurs. It might be at, depending on what u of x is, it might be at 0, it could be anywhere. So we do have that break in the derivative. Okay, so let's go ahead and use this. So f prime is going to be over 3x minus 6 over 3x minus 6, like that, times 3. Okay, so that's all I did. I just took my function, divided by itself. So this preserves the fact that this really is just a plus or minus 1, but there is a break point right at 2 where that occurs. And this is preserved right there using this form. So essentially it simplifies, but it is undefined at x equals 2. It simplifies to a plus or a minus 1. So your derivative is a plus or minus 3 and undefined right at x equals 2. That's all it tells you. So this is a convenient way to write that absolute value function, to be able to work with it in the form there. Okay, all right, next one. We'll have g prime is going to be an x squared minus 2 over absolute value of x squared minus 2 times a 2x. And so it's a nice closed form that you don't have to worry about using the the piecewise defined function. You don't have to use that if you write it this way. Okay, next one, we have h prime would be, okay, we've got a cosine of x over absolute value, cosine of x. And then we have times a negative sine of x. So that's all there is to it. Okay. And again, you can see the preservation of that undefined value when the cosine of x is actually a 0. This thing will be undefined. So that would be in several places, odd multiples of pi over 2. We'd end up with zeros in here, pi over 2, negative pi over 2, 3 pi over 2, etc. So there'd be a lot of undefined places for this derivative. And that's if you saw the graph of that, quick graph of this, I mean, think about it. Cosine does this. Okay, if you're going to take absolute value of the cosine, you're just going to take this. Every place where it has a 0 crossing, it's going to bounce off like that and come up like that. Okay, so all of this part in here comes above and back down here, and then again. So you're seeing this function here. And every place that has one of these points here, these cusps, these occur at odd multiples of pi over 2. First one at pi over 2, next one 3 pi over 2, etc. Okay, so that's what that function looks like. And that is the slopes are now represented by this function. So notice undefined slopes at these points in here, because that's what this original function looks like. Okay, it looks like this. This is just a cosine. This is cosine of x, like so. So you see where we're getting those undefined places. Okay, all right, so that's enough of that.